Hi there. Today let's talk about multiplying with exponents. And for our first example, we're going to compare x to the fifth power times x to the fifth power versus x to the fifth power plus x to the fifth power. So let's start with the expression on the left. X to the fifth, remember that represents repeated multiplication. So we have x being multiplied by itself 5 times. When we write it out the long way, it looks like this. Same thing over here, x being multiplied by itself 5 times, and they are being multiplied together. So altogether, we end up with x to the 10th power. There are 10 x's all in a string being multiplied together. Shortcut for repeated multiplication is using an exponent. Okay, on the right, we have x to the fifth plus x to the fifth. So when we are adding or subtracting, we call it combining like terms. X to the fifth and x to the fifth are like terms. They have the same base, they're both x's, but in order to be like terms, they also must have the same exponent, and these do. So I have one of them here. We're just not writing the one because we don't need to. There's one x to the fifth here and another one here. So altogether, I have two of them. This is 2x to the fifth. So the difference is here we're multiplying and we end up with x to the 10th power, 10 x's all being multiplied together. Here we have two of the same thing being added. As long as these are the same, it doesn't matter what they are. We have one of them here, one of them here, so altogether we have two of them. Just to kind of remind you of how to combine like terms, here's another quick example like that. We have two terms and they are like terms because they're both x to the fifths. So we can go ahead and add these. Here we have 3 of them. Here we have 8 of them. So altogether we have 11 of them. They are still x to the fifths. We just have 11 of them all together. All right, so let's look at another example. For example 2, part A, we're going to be multiplying 5m with 3m to the second. Remember, when you have two sets of parentheses sitting right next to each other, it's just another way to show multiplication. So this is the same as 5m times 3m to the second. It's just another way to represent the multiplication. So here, this is just 5 times m. And over here, remember the power of 2, exponents only affect what they are next to. So this 2 is only affecting the m. It does not affect the 3. So this could be written as 3 times m times m. Then you want to go ahead and combine your numbers. So multiply 5 times 3, because this is just one long string of multiplication, gives us 15. And then we have m times m times m, which is m to the third power. All right, for example 2, part B, let's do another comparison. 7x to the second power times x to the fourth versus 7x to the second power plus x to the fourth. Over here, we've got a long string of multiplication. 7 is being multiplied with x squared, which is being multiplied with x to the fourth. This power of 2 only affects what it's next to. So it only affects the x. It does not affect the 7. So we could write this out the long way as 7 times x times x. And then this would be x to the fourth, 1, 2, 3, 4 x's all being multiplied together. So when we're all done, we have a 7 being multiplied with a lot of x's. How many x's? 1, 2, 3, 4, 5, 6. So 7x to the sixth. When you write it out the long way, you can see why there is a shortcut of just adding the exponents. When you're multiplying and they have the same base, you can just add the exponents. We're going to have a lot of shortcuts as we talk about exponents, and sometimes you get them mixed up. So it's best if you do remember why the shortcut works and how to write it out the long way, just in case you find yourself in a situation where you're like, do I add the exponents? Do I multiply the exponents? If you can write it out the long way, it's a quick reminder of, oh, we definitely add the exponents here. So when we're all done, 7x to the 6th is as simplified as we can get this one. On the other side, we have 7x to the 2nd plus x to the 4th. So since we are adding, we are looking to combine like terms. Even though both of these have x's, because they have different exponents, these are not like terms, and we cannot simplify it. It is already as simplified as it can get. It will just stay 7x to the 2nd plus x to the 4th. We cannot combine them because they are not like terms. So just pay attention as you're doing your work to notice whether you're multiplying or adding, because sometimes if you do a quick glance, you might multiply everything when really it's an addition problem and there's nothing you can do. All right, in this example, we have one exponent. It's a 5, and it is only affecting what it's next to. It is next to an r. It does not affect the 4. If the 5 were on the outside of the parentheses, it would affect everything inside of the parentheses. But because it's inside and it's only next to the r, it only affects the r. So this is still just a long string of multiplication. They're just using parentheses. We could even add parentheses here if we wanted to, or you could write it out as a long string of multiplication. -1 times r is being multiplied with 4 times r to the 5th, which is 1, 2, 3, 4, 5 r's all being multiplied together. And now it becomes the same thing we've been doing. Multiply your numbers. -1 times -4, -1 times +4 is -4. And we have 1, 2, 3, 4, 5, 6 r's being multiplied together, so it's r to the 6th. If you're looking to use the shortcut, up here we have r to the 5th and r to the 1st power. We just don't write the 1 because it's not needed. There's only one of them, so we don't need to write the 1. But you do need to remember there's a 1 there, so 1 plus 5 gives us the 6 here, and you just multiply the numbers. Okay, one last example, just because I know you'll see one of these on your assignment. Well, not just one, but a few. So we have a fraction inside the parentheses and an exponent on the outside. So that means we have 4 3/5 that are being multiplied together, and they are being multiplied with another set of 4 3/5 being multiplied together. Okay, so here's an example of writing it out the long way, and it's kind of tedious. So it's nice if you do feel confident about the shortcut. So 3/5 to the 4th power ends up being 4 of them all being multiplied together. We have another 4 of them all being multiplied together here, and they are all being multiplied together to give us a total of 3/5 to the 8th power. So knowing that shortcut and being confident that it's going to be to the 8th power and not to the 16th power is really helpful. So the shortcuts definitely save you some time, but you want to be confident you know what they are. I hope this helps, and good luck with your assignment.